In section 4.3, we discuss solving x squared plus bx plus c by factoring. So we originally start out with some sort of trinomial. We will get to the point where we just have a binomial that we factor as well once we discuss patterns. So we are going to be solving by setting it equal to 0. So what happens when y is 0? We are going to be looking at when y is 0, we're talking about our x-intercepts. So sometimes we have 2 intercepts, and sometimes we have 1. And we're going to be looking at the different possibilities here and what it means. So overall, when we set it equal to 0 and when we solve, we are looking for our x-intercepts. That's the whole idea. So we are factoring in this section. So what that means is it's going to end up factoring into 2 binomials or a binomial and a monomial. So in your textbook, they originally write x squared plus bx plus c, and then they write it like this: x squared plus the quantity m plus n times x plus mn. So what I said in class is we are looking for factors of c that add to b. So the very basic example is x squared plus 7x plus 12. So I had you write it like this in class. What are factors of 12 that add to 7? So you might be looking at, multiple factors here. It doesn't hurt to list them all out, but if you can recognize that a positive 3 and a positive 4 add to equal your b term here, that means x squared plus 7x plus 12 factor into x plus 3 times x plus 4. And you can FOIL that out and confirm it. So that was the general process behind a simple example here. So let's do another example. I have x squared minus 3x minus 18. So what factors of negative 18 add to negative 3? So I'll give you a second. You can pause the video and see if you can figure it out. Factors of negative 18. So I'm going to go ahead and write out a couple of possibilities here. Alright, I think of 2 and 9, 1 and 18, and 3 and 6. So is it 6 and negative 3, or is it negative 6 and positive 3? So remember to add them together. 6 plus negative 3 is a positive 3, and negative 6 plus 3 is negative 3. So these are the winners. So it's going to factor into x minus 6 and x plus 3. Alright, then we recognize a couple of different patterns that they list out for us on page 253, one of which is the difference of squares. So it says if it looks like a squared minus b squared, it's going to factor into an a plus b and an a minus b. This is where we don't have a trinomial. There's only 2 terms. So we can list out a bunch of examples. X squared minus 9. Well, my a squared is going to be x squared, and my b squared is going to be 9. So that's going to factor into x plus 3, x minus 3. All right, and you can FOIL it out, and you would see that the positive 3x and the negative 3x cancel out, which is why there is no x term, no b term here. All right, another example. 4x squared minus 25. This is a little bit different. There's a number out here in front. Well, what squared gives you 4x squared? So what squared gives you 4? That'd be a 2 and a 2. What times what equals x squared? X times x. And so that's 2x plus 5 and 2x minus 5. That's the example we ended on in class. Alright, so that is the difference of squares. The reason why it's different is that minus sign and difference of squares. Alright, so the next pattern is a perfect square trinomial. And a perfect square trinomial is going to fall into this category where we can factor it into an a plus b times a plus b or an a plus b squared. It's a little bit different and the formula seems a little ridiculous, but once we start writing out examples, maybe we'll see what I'm talking about. Alright, example. X squared plus 6x plus 9. It's going to factor into an x plus 3 times an x plus 3, or x plus 3 squared. All right, the middle term is going to be double whatever a times b is. X squared plus 8x plus 16 equals x plus 4 squared. X squared plus 22x plus 121 equals x plus 11 squared. X squared plus 2x plus 1 equals x plus 1 squared. Alright, if you don't memorize this, that's fine. We can go about it by finding the factors of c that add to b. Alright, these are just patterns that we recognize, so they're shortcuts, so you don't need to memorize it. It's just all about recognizing. And there's one more perfect square trinomial. The only difference between this perfect square trinomial and this one is the minus sign. So I'm just going to switch the minus signs on us. X squared minus 10x plus 25. It's going to be x minus 5 times x minus 5. Or x minus 5 squared. X squared minus 14x plus 49 equals x minus 7 squared. And how do I double check that? X minus 7 times x minus 7. Well, when I FOIL, I do get the x squared. And then I get a minus 7x and a minus 7x. That's where the 14 comes from. And then a plus 49. Alright, so 14, it checks out. I factored that correctly. And the last piece of this section discusses the zero product property. So if I actually set my equation equal to 0, it says that I've got a product here, a times b. Alright, I'm going to work an example out next to it. So x plus 2 times x minus 3. Alright, let's say I've already factored it. It says that if 0 equals the product, a or b must equals 0. Alright, that makes sense. If 0 equals, I don't know, if a is 7, b has to be 0 because I need to multiply two numbers to get 0. So what that means for us when we're solving these problems, x plus 2 has to equal 0 or x minus 3 has to equal 0. So that means x equals negative 2 or x equals a positive 3. So if you remember when we were talking about intercept form, I'd said what it reads on the inside we actually need to think of as opposite. So since it reads a positive 2, my root or my 0 is actually a negative 2. Since it reads x minus 3, my root or my 0, my x-intercept, is a positive 3. So let's look at some more examples where we solve. So we're first going to have to factor and then we solve. Alright, so a problem is going to read solve c squared minus 9c plus 18. Alright, so we need to look at factors of 18. I'm going to conveniently pick 6 and 3. Well, 3 plus 6 equals 9, but that's negative 9. So let's try negative 6 times negative 3. That does give me a positive 18, and that does add to negative 9. So I get c minus 6 times c minus 3. All right, and if it said solve, there would be an equal sign. So if c minus 6 times c minus 3 equals 0, that means c minus 6 must equal 0, or c minus 3 must equal 0. So c must equal 6 or a positive 3. All right, another example where it says factor and solve, or solve by factoring. I have got x squared minus 11x plus 30 equals 0. So factors of 30, I automatically am going to -5 and -6. So that's going to be x minus 5, x minus 6. If that equals 0, just like from intercept form, x equals positive 5, positive 6. So 5 or 6. And one last example to challenge you all. Actually, we'll do 2 more examples. R squared plus 2r equals 80? Huh, it equals 80. Well, I'm used to it equaling 0, so I'm going to go ahead and move that 80 to the other side to get it into standard form so that I know. Okay, now I want to factor -80. How about 10 and 8? So let's do -10 times 8, or is it positive 10 times -8? I'm not sure. When I add them, this is the pair that's going to give me the positive 2. R plus 10 times r minus 8 equals 0. So that means r equals -10 or positive 8. And then one more example. M squared equals 7m. All right, I want to get all the terms onto one side here. So I'm going to subtract 7m. M squared minus 7m equals 0. All right, this one's different. There is no c term here. There's no constant. So then I factor out what I have common between the two terms. So what do those two terms have in common? That is an m. So I'm going to take away an m. I'm going to undistribute an m. I'm going to put it on the outside and put everything that's left in parentheses. Then I'm going to set both pieces equal to 0. Well, if this piece equals 0 and this piece equals 0, my two options for m are 0, comma, and 7. 0 or 7. M equals 0 or 7. All right, if you guys have questions on factoring x squared plus bx plus c, please let me know. See me before or after school, or send me an email.